change it off. There we go. Yeah, sorry about that, guys. This was picking it up, right? So my microphone was connected, so I didn't realize that that was busted over there. That was probably real good for sending ground saying he had to put his baby to sleep. You know, I'm just sitting here talking to myself. But yeah, I was talking about like there's kind of like two things that are kind of important to getting into Linux, right? I mean, I would say the first one is learning Linux, right? You just got to be able to get at a command line. You got to be able to stomach the command line. If you can't do that, I mean, there's always Windows, I guess, right? But if you can stomach the command line and you want to get better at it, you just got to get your hands on it and start doing it. That's one. The second part of this kind of this world that we live in here is how do we make people believe that we can administer and build these systems for them, right? How do we prove that we know like what we're talking about? How do we prove that we are responsible enough to like not just go rm-rf/ like everybody always giggles about on the internet? Like how do we make sure that like we're doing the stuff that we should do, right? So fortunately for us right now, we're just talking about the simple stuff, which is just hands-on Linux, right? So this lab says you're a new system administrator at a company. You've decided you need to start gathering system information so that you can use it in scripts. You know that this will give you more capabilities for automation and collection of system state. So you've decided to use the tools at your command. Instead of just doing one-offs all the time and typing as fast as you can, you realize that even if you are one of these elite guys that can type at 180, you're still not going to get more done than somebody who figures out how to use their tool, right? It's like, I often people will talk about like, I guess I was going to use the resume example, but like if you ever see a carpenter, carpenters will carry 30 hammers with them, but when you meet old carpenters, they really only ever use one. They've got all these other ones, but they really can just do whatever they need in one. So it's kind of the same idea. Like I don't even know where I was going with that, but the point is learn how to use your tools. Anyway, so we're going to check out the bash environment variables. What do we have with us just because we're simply sitting in a shell? I mean, we know we're in a shell of some type, and we happen to know it's bash because that's how we interact with Linux most of the time. But when this thing was instantiated, when we came in and logged in, SSH'd in, did whatever we did, what kind of environment are we in? Like, this would almost be like if we were in a text-only game and we were just going to like look around at all the walls around us, right? Like, what's going on with us? Yeah, Dav, how's it going over on the YouTube side? We're just doing basic Linux, right? So we're going to learn about variables and conditional testing, and then given a bash prompt, complete in the allotted 60-minute time and complete all the activities of the lab. So let's go look at this. Let's check all of our environmental variables. We can say print env. It's going to dump a whole bunch of stuff to the screen. And we can go start looking at our variables. So here's our variable name over here on the left. Here's shell. And the shell is equal to bin bash, right? That's the value. So it's almost, when we think of like key value pairs, it's very similar to that. But we've got the path working directory is root. Here's our home. So our home happens to be the same as root. And then our log name is KC internal. And I'm going to show you some stuff that we kind of assume because we've been in Linux for a while, but some things that are true. Let's just for fun, let's take these two right here. In fact, if we wanted to, we can do our print env and then grep for root, right? And there would be our two. And I'm going to do something kind of silly for a second. And I'm going to say home is equal to temp, right? And then now when I say print env grep, let's say we look for pwd and home, right? Whoops, like that. And then, well, that gives us a little bit more than we probably wanted, but for this, we can just see that we have this. Anyways, my point in showing you all that was now one thing that we're very used to doing is like saying cd to tilde. And where did that take me? Well, that took me over to temp right now. But in our normal environment, when we normally have an environment, cd tilde will take us to home. But it doesn't really ever take you to your home as defined. Like if we were to grep root from etc passwd, it doesn't actually take you to your home that's defined here. That home is defined and set when bash is instantiated. But if we modified it like I did, now it's going to send me to the home that's the environmental variable of home. You might say, Scott, why are you telling me this? Well, because I want you guys to understand, even if you know a lot about the shell, it's fully customizable for you. You can change all kinds of behaviors and all kinds of things. You can even make your own variables up in here. You don't even have to you don't have to modify home if you don't want. You should leave home as home normally, but the point is, you can do almost from what's initially set up, you can change all kinds of variables. But then also, as you get into this and start dealing with variables, you can also change how the variables are set up to start, and that's with your .bashrc file and different source. You can source as many files as you want in that file. You just keep making files source and keep adding variables and conditions and all kinds of stuff. The one thing I always caution people on is the more you build up your environment, the more you're going to be dependent on that environment eventually, right? So let's keep going. So printenv and env are going to give us just a bunch of variables, a bunch of stuff about the environment. We see that I've changed home to temp, so that's kind of weird. And then we see this one, ls colors. And I say, what the heck's an ls colors? Well, there's a bunch of, when we do ls, there's an alias that actually causes it to do color auto. And these are the definitions of colors. So right here, there's a definition for anything GZ. Anything that has a GZ on the end is going to be a different color. Could we prove that to ourselves? Could we come right here and do a PWD and an ls? And then could I touch a file.gz? Now, we know it's not actually a gzipped file, but then if I do an ls again, does that file.gz show up as a different color? Yes. Does it show up as a different color because it's that file or because it has that extension? I'm not trying to be tricky here. There's a definite answer to it. The answer is it's right here. If .gz, which we happen to find right here, .gz is defined right there. So if I were to take that extension off, again, that file is not actually a gzipped file, but it's showing up as a gzip file. So this is another one of those things that I tell you guys, you can't always lean on these. You can't always trust that those things are correct. There's other things that we can do to a file. We can stat file.gz and we might see some information about it. We might, if you want to see if something's like binary or executable, you can do strings on it and it'll give you information about the file. This is just a file we made up, so it's just an empty text file, really. Yeah, it's a regular empty file. If I put some ASCII characters in it, it would come up as it wouldn't be empty, it would just be a text file, right? So my point in showing you all that is there's all these things that you can kind of know about your shell. We could do declare-p. This will show you all kinds of other stuff. There's a bunch of variables here. And then we can also use set. Set gives you by far the most about what's going on. But when I look at all this, I go, man, that's a lot of, that's a lot of info, man. I don't really want to be dealing with this. So I'm just going to do a print env and pipe it through word count-l. So that WC is word count, but then we can limit it down. We can say, hey, I want you to behave a different way by giving it this option. And -l is going to give us 17. Environment with a pipe to word count-l is going to give us 17. And then declare-p gives us 64. And set gives us 66. So what does that mean? It just means that's how many lines came out. Doesn't even directly relate to variables, right? It doesn't tell us the exact number of variables anyways. But the point is, there's all kinds of information going on in here that might be useful to me. And at some point in the future, I might need to pull that out and compare it to something else. And because of that, and because I understand this simple thing, it makes like what might seem otherwise complicated. So something that's actually really simple is I'm just going to take two things and compare them. Are they the same? Ooh, they're not the same. And then I just throw one out or I don't do whatever action I was going to do. And if you can do that, like I often tell people, because I've 17 years of teaching college, I've had a lot of like programming and logic classes where students are like, I just can't do this. It's so hard. And the syntax and this and so I'm like, it is the syntax that's hard. The logic is simple. And you say, what do you mean? And I'm like, you couldn't have fucking drove to the school tonight. You would have crashed your car at the first light. You'd have saw that it was green and you would have saw that it was red and you would just crash into something. Because you wouldn't have known if you could go or not. You're testing conditions all the time, guys. All the time. Your brain is constantly testing conditions. So, Xshania said judo all Linux. Yeah. I do very little judo. I mostly do Brazilian jiu-jitsu. which is just lazier because we start sitting down already. We don't actually throw each other too often. Well, we do throw each other sometimes. It just depends. So let's go down here, and we saw all these variables that are built in. Again, there's all these variables that are kind of given to us, but let's see if name is one of them. So I'm just going to test the output of the echo name. Well, there's nothing in there. And what is that doing? So I'm echoing out the box labeled name. Let's say that the label on the outside of the box is name, and I'm shaking out whatever's in it, and nothing came out. There's nothing in that box. In fact, that variable didn't even exist until we just tried to echo it out. That variable didn't exist in memory. It didn't exist anywhere. So then I'm going to come down here and I'm going to give that variable a value. We're going to use the uname command and see that we're on a system called Linux. Okay, uname went and queried something somewhere and told us Linux. It queried the proc CPU info, right? So it gave us info about the kernel. Not CPU info. Kernel info? Kernel. It got us kernel info. And now I'm going to take that and I'm going to throw that into that variable name. So the output that was right here, this is a process right here called interpolation, but nobody's ever going to ask you that. But $ and then a open paren and a close paren will dump the output that was going to come out of here, which is Linux in this case, into the word name. So if I just press up a few times, I would expect this to say Linux right there with a capital L. There we go. And this equal sign, just so you guys know, you might often think, oh, that's an equal sign. Equals is equals. Does it equal this? No. When you use one equal sign in Bash, and in most programming languages, if we're being honest, but in Bash, that's called an assignment operator. And I always, instead of remembering that, I always just think of it as like a little dump truck. Everything to the right, whatever is evaluated or interpolated in this case, is going to dump down into the box with that name on the outside of it. It's as simple as it is. Nothing more complex than that. And now this variable name within this shell, and only within this shell, is going to have a value. Let's do something real quick. Let's say bash and go to another bash shell that's a child of the shell we were just in, and let's echo $name. Now, I'm going to ask something for the more senior people around. Is this going to have a value in it, or is this going to be an empty box in the child's shell? So now we're in a child process, a shell underneath the original shell, if you will, spawned by the original shell. Is that value going to have something in it, or is it going to be empty? Well, as I often say in engineering, one test is worth 1,000 expert opinions. We could sit here all day and argue about it, right? People are going to pull up old bash cookbooks and old tldp.org and we can guess, or we can just hit the button and say, nope, it's empty. Now, some of you probably know why it's empty. Let's exit and go back up to where we were. Now it's back. Well, the reason is a thing called variable scoping, and this is a locally scoped variable. We have not exported it so that the child processes can have it. Now, if I export name, that should work. Then we go down in there, we echo name. Now the value is down in that one. Because once you've exported a variable, that variable will be available to all subshells and subprocesses spawned from this one. Also, I didn't show you guys this, but you have a special variable. You got a bunch of special variables in Bash. The special variable of $$ is the process ID of the program you're in. So to prove real quick what we were saying earlier, this is definitely a spawned shell. It is a new process ID down there, right? And because I have taken that name and passed it in, or made it, I've exported it, it is now available in that lower shell. So if you ever get lost, you can always use that. But I would highly advise don't do a lot of jumping around in shells unless you kind of are more familiar with what's going on. Also, like in sysadmin type work, that's not going to be needed very often. Sometimes you'll jump into other boxes, sometimes you'll jump into other users, but actually spawning subshells and doing stuff in those, that's less useful as an admin type thing. So maybe we'll put that over in the we don't care that much about it. All right, we come down here, we echo name, we see the name, and now I say let's go check to see if HTTPD is running on this system. So we do a ps-ef and we grep-i for HTTPD, and then we take we do that same we take the actually the exit code of that. So let me show you guys what we're doing here. This is kind of interesting to see. when you do some value like that, when you search for something and then you echo $? This will give you the last return code, right? And that is a return code of 1. That is not good. Well, it's not bad. It's just it didn't find anything. A return code of 0 means everything returned good. So let's check another one. Let's do this one. And then this one is actually going to have found something. So I'm going to run that. And then I'm going to do my little echo $? And I'm going to have a return code of 0, meaning that grep found something. So now, if I was looking for something to be running, some process before I ran my script, what I would know right here is that the echo 0, the return code of 0 is analogous to I found something, and 1 is analogous to I did not find anything. And actually, you can get all kinds of other error codes, so I would just search for 0 as good, and then anything else is bad. But that's good to go. Yeah, empty because we didn't export. Exactly right. That's exactly right, Makondo. I missed that earlier, by the way, but yeah, that's 100% true. So we keep coming down here a little bit, and I say, can you verify that's correct? Which one is running and which one's not running? Well, HTTPD is obviously not running on the server because we don't have a process ID for it. Nothing came out. And then we made start or SSHD check did have something, so it got a 0. So then we go to look over here. HTTPD is not running and SSHD is running. Okay, that makes sense. Now we talk about dropping into shells. So these are the questions over here. Name, well, does that still have the variables? The other one, and that's it's not going to until we export it. I say, what is held in the variable $? And why does it matter? $? Always holds the variable of the last return code from something, and it's useful because it's really useful for us in testing things, because I want to test something. If I was looking at the system and somebody ran ps-ef and looked for HTTPD, I would go, well, it didn't have it. It's good. And I would go about my day and either install HTTPD or say that web server's not set up, and I would leave, whatever I would do. But this one, I clearly see that SSHD is running. But I don't have I don't have my eyes to look at everything. I have to use scripts, and I don't want, do I want to be up at 2 a.m. running scripts on servers or just running commands on servers? Hell no. I want my scripts to do it, right? And again, maybe deploying stuff is not the best way to do that. But let's say that, this is just checking to make sure that a process is always running. Well, my script can then check, and then we can have 0 is good, 0 is go back to sleep. 1 or anything that's not 0 can be alerted to us. So that's kind of a important thing to understand in that sense. Okay. So we come down here and I say test the decision structures of Bash. And I say there's 3 decision structures, and this is computer science. This isn't even just related to Bash in general. This is generalized computer science. We've got single alternative structure. I don't know why that has an S on the end of it. I guess that's fine. Dual alternative and multiple alternative. These are the ways that we make decisions. These are the ways that systems make decisions too. So let's talk about them real quick. The first one is we're going to use a single alternative structure to output whether or not HTTPD or SSHD are running. So the first one is going to look like this. It says if HTTPD check equals 1, then echo HTTPD is not running, FI. And HTTPD is not running because we knew that check was 1. We checked that earlier. Then we say if SSHD check is equal to 0, then echo SSHD is running. Now, some of you are very quickly going to look at this and go, well, yeah, if you know the condition, that's great. If you know the condition that you expected because you wrote the lab and you did the stuff earlier, well, that's great. But that doesn't help you. What would the program do if HTTPD check had been set to literally anything else in the world? It would have bypassed this block of code and never run it. And this right here would have run if the SSHD was not on, or if this was any number other than 0, we wouldn't have gotten an output. Because this is a single alternative structure. Single alternative structure is like you're walking down the road, right? You're executing top-down procedurally, and you come to a condition that's not true, so you go, and you just continue on. No decision was forced right here. There's no forcing of a decision. My program just, it like hopped over like it was like doing hopscotch, and it just jumped over that part of the program. It's never going to execute it. Doesn't care. Hey, thanks for that. Happy affiliate anniversary over on the YouTube or on the Twitch side of things. Yeah, I actually hopped on a little bit ago. I worked all day, and then the wife came home, and I was finishing up my college class, and she was like, "Are you streaming tonight?" And I was like, "Yeah, I want to kind of stream a little bit tonight." And then when I hopped on, I saw that it was like my affiliate anniversary, and I was like, "Oh, I didn't even know that that was today." So yeah, thanks for that. I appreciate that. Um, we're going through the book and we're doing variable logic, right? So this is a single alternative structure, and you might very astutely note this is not great. This is not a great way to run a program. It doesn't force a path. It just, if it's there, it's there. If it's not, it's not. And for like simple checks, this is fine. Make sure a web server's on. If it's not there, let's just leave the program. A big one, make sure that the user running this is root. That's a huge one. Another one is make sure that they're like Oracle. Maybe you're doing like an Oracle account and it has to set everything up as the Oracle or the grid user that's going to run the program. And it tests all the permissions and stuff within that user, so you need to be that user to run it. That's a very common way to set up databases and stuff. But okay, let's just say, and by the way, Oracle still to this day, last I checked, and that was only within the last year or so, it was still being deployed via scripts, right? When you would deploy Oracle servers, their official method was still just scripts, and you can go take the scripts apart if you want, but you need to make sure that the things work the way that they're supposed to. All right, so anyways, I come over here, and I say, let's do a dual alternative structure with those same values. I haven't changed any of the values yet. Hey, Robodom, how's it going? Good to see you around. Yeah, it is my affiliate anniversary. I didn't even realize it when I started streaming. Like, or while I was talking to the wife, and I was like, oh, look, it popped up and said that I have this, so that's kind of funny. Anyways, come over here. Let's look at a dual alternative. And real quick, you're going to say, well, Scott, hold on. You did the same thing. You said yes and no. So you said if HTTP check equals 1, then echo it's running, else do something else. Say it's not running, right? Or it's not working. So it's not working or it is working. And then here I said, if it's here, echo it's running, else echo it's not running, and then we saw that. But I want you guys to understand the difference in what's happening in the system. In the other one, in a single alternative structure, procedurally executing, get down there, jump over the code. Here, procedurally executing, just walking down the line, just humming along, doing bash stuff. When I got here, my program is forced to go one of two ways. There's no jumping over this anymore. This if condition, you say this is structurally no different. It's an if and an fi. But with that else, now we're forcing a condition to happen. You're either going to be the one thing, else you're going to be the other thing. You're walking down the split path one way or the other now. Does that make sense? With a single alternative, it just hopped over, didn't give a shit. Never executed the block of code, nothing. This is going to execute something. We are going to do something in this test. And again, this is very, very simple, straightforward computer science stuff, right? Bash aside, this is just... All right, so then I can do multiple alternatives. Multiple alternatives, or what we call select or case in Bash, is we're just going to run a case statement. And that case, and by the way, I'm squishing all together as one-liners, but if we were writing as a script, this would be a lot more spread out. And the case is SSHD check, and then it looks for 0, so SSHD is running. It checks for 1, it's just SSHD is not running. And then it checks for that catch-all, anything else, something is really wrong. Because I expect a 0 or 1. Those are two well-defined doors that we could pass through. But then there's this other for just everything else in the world. Everything else that could have happened is over here. So I say, can you do the same thing for HTTPD check? Yeah, I think so. I could say case in HTTPD check. All right, as long as I spell it the right way. And I could say, if it's 0, HTTPD is running. And if it's 1, HTTPD is not running. And then now I know that it was not running. Now, hold on. I want you guys to see something about this. When we did our dual alternative structure, did you guys notice I had to switch what we were originally checking for, 1 or 0, and then the else was the catch-all for everything else? Do you notice that doesn't have to happen in a case statement? In a case statement, I just define the two things that could be, and I define their output. These did not change. I mean, aside from the echo. But the actual test of the logic, the 0 and the 1, did not change, which actually makes case pretty powerful for you. So, sorry, actually, I missed some of this stuff. Yeah, that's all good. Good looking out. Oh, Amir, you asked a good question. I'm sorry. I should have saw this earlier. Yeah, this is actually a little trick that I was taught by a guy that I used to work with. And he Lou was great, man. Lou had his own. He was kind of like, any of you guys ever remember Parks and Rec, and how he had like Duke Silver, like the guy who sang and or what did he do? He played like saxophone or something, but he never let anybody know about it. Remember that Duke Silver? This guy that I worked with, he had like a whole jazz album that he had put out. He played like nightclubs and stuff like that, and none of us knew. And he brought him in one day and showed it. Anyways, he was really good with Jenkins and really good with scripting. And what he showed, yeah, he was like Ron Swanson, but what he showed me was this, because like what I used to always do was this. I would do grep-i httpd grep-v grep, and you'll get the same net effect. Watch what happens if you don't do. Let's use SSH because it's running. Right, SSHD is running, but you found two things. You found the process that you wanted, and you also found the grep. So we used to go like this, and we would grep-v grep. But I want to show you why this other one is so clever, is because here it's regex, right? But then when you search for it, when it comes out down here, it's the actual value of SSHD. So you won't find the grep because the grep will have those included on it. So you're excluding the grep without having to exclude the grep. It's brilliant. I did not come up with it. I tell you guys when I show you this, I did not come up with this. So the question over on the YouTube side was, why do we use those square brackets with grep? Because we don't have to remove the grep then. So if I wanted to know how many processes of SSHD were running on a server, I would get one. I would be incorrect by one if I didn't remove the grep. If I had multiple because sometimes you have multiple SSH shells running or SSH daemons for different reasons. Maybe you have another way to get in a server on an alternate port in case the main user port gets all backed up or something. And that does happen on servers, especially like login type servers. So we'll have a different port to get in on them, clean up the BS user crap, and then let the users come back in when they're not all. They'll just be like cattle rammed up into and not being able to get in anymore, and then you got to clean them all out. All right, so anyway, so we did that, and then it says, now that you've done some basic decision logic, let's add in an inclusive OR and an exclusive AND to the equation, okay? So then we have a little bit of this. Also, my brother's coming over, so I might have to get up here in a minute. So we might go on break here in a minute. But I said, why is it so important that $? is immediately run after the last command you're trying to capture the return code for? Well, because it only exists for that command right then. You can only capture it on the next. All right, anyways. So now we're going to go check that if it equals 1 and SSHD check equals 0, then echo this system is good. And then FI that. And then we got too many arguments. That's not good. Did I mess that up? I'm sure I've never. Oh, wait, hold on. I think my shell just hold on. Yeah, my variables are empty. I don't know how that happened. When that just wiped, it wiped my variables. So let's go back and just generate our variables again real quick. So here's our right here. Boom, there's our two variables. We'll just check, move forward, check, move forward. And then right here, let's run this. And now it'll say that the system's good because the values are as we expect. And then we'll try it with an OR logic. And only one of these is good because it's if this HTTP check or this SSHD check is good. And in this case, the SSHD check is bad, but HTTP, oh, they're all bad. They're both bad, I guess. But then the system is good as we expect. So one or the other is off in this case. In this case, both of them are off, but the OR allows it to not matter, right? From a conditional truth table, this is true if this or this are true, and this one is true, so it's good, and that one is not true. Okay, my brother actually just got here. So here's what we're going to do, guys. I'm going to pause my, turn off my camera for a second. Let's go on break real quick, hourglass, and then say 10 minutes. Quick break, guys. I'll be right back. All right, sorry about that, guys. I had to go run real quick and meet my brother downstairs. He was dropping stuff off for me. All right. So, let's go do a couple of things from the book here. All right. So, yeah, everything's going good here, Robodo. Yep. All right, I'm gonna leave the break going, but while you guys are kind of on break, let me show you guys some other stuff we got going on. I got the Linux automation course. I'm gonna start working on that hardcore this weekend. We've got more lab operations to clean up. I do have to finish building some stuff. I'm not gonna do that right now. But for sure by this weekend, I got to get all the target servers up, so you guys have target servers to hit for your automation course. I'm going to give you guys plenty of room for that and stuff for that. But let's go look at Wikipedia. Let's go look at truth tables. If you've never seen a truth table, this is what a truth table kind of looks like. It's logical connectives, and then you can learn a lot about basic algebra and stuff like that. Yeah, Quartz One, I have a con board, yeah, in the home lab. This one's old. In fact, I have old stuff in here that's like super, super old. Like from years and years ago when I first started streaming. Jerry Podepi said, hello, I'm new here. I know if your sysadmin course is enough for me to clear RHEL 10. No, the course doesn't focus on any one Linux certification. Oh, let me turn my let me turn my camera back on. Hold on a second. The course does not, the Linux sysadmin course, this thing right here, it is not catering to a specific version of Linux. I mean, we go off of Rocky 9, 9.6 in fact in the lab, but and some of it's also done in Ubuntu, so that we've got like a balance of it. But yeah, no, I do not force you guys to do RHEL stuff, and I don't think it's enough to do your RHEL certification. What I always tell people is if you were trying to clear like RHEL 10 cert, you know, let's say you were going to go for the Red Hat cert, what I would tell you to do, I would tell you to go find the cert here. All courses and exams. Here's Red Hat certified RHCSA, right? I imagine you're talking RHCSA. And then here's the exam. And what I would do is I would come in here and I would find out all the objectives. And I've shown you guys this before. I would go grab every objective right here. I hit Control C, and I would go over here, and I would then just drop it over here, and then I would go through and make sure that I knew how to do all of this stuff in one of those labs, one of those environments. That's how I would do it. I'm not working on one of those certs, but that's how I would do it if I was prepping for that cert. All right, so truth tables here, you can look at how logic works, and you can study this a little bit if you want. But essentially, if you're talking about logic, right, and truth tables here, we tend to look at and or, and this should be right here. Boolean logic uses this condensed truth table notation right here, and then it's true and true. So this is a and, right, and this is an or, and I know that because right here with an and, you only get a truth output if you have this and this are true. So I went to the store and I went to the park. Well, if I told you that, that's only true if I went to both places. Everything else, if I went to the park but not the store, false. If I went to the store but not the park, false. If I didn't go to either, false, right? So this is truth table logic. Or if I said I went to the park or I went to the store, that's true if I went to both, because I did do one or the other. That's true if I went to the park but not the store, and that's true if I went to the store but not the park. But it's not true if I didn't do any of those things. That's a lie then. So that's how these truth tables work right here. And this is the basic thing that I want you to understand in and or logic. There's a whole bunch of other stuff that you can go work into, and it gets more and more complex, but most of what I use for Bash is these ones right here. And you don't really need to go look them up anymore. Once you know them, you just kind of know them, right? So, so hopefully that answered the question, though, that this is not designed to make you clear any one cert. This is designed to help you get our whole course. Both of our courses are designed to, if you're doing the sysadmin course, it's designed to get you in at kind of the bottom of the carousel, starting out as like a Linux sysadmin. You understand how the work comes in, you understand what the work looks like and how it kind of applies to these different technologies that you're going to run into as a sysadmin. The security engineering course, it's much more built to help people transition out of that role into more of a, this is more of like you're starting to build servers and understanding how compliance works, which is very valuable in general, but this is heavily geared towards like you're starting to build servers and understand why they're built. Great for running home labs and doing security and stuff, but the goal is to not just check compliance boxes, which is what a lot of security engineers and Linux engineers do. We just check compliance boxes. No. We need to know when it's time to push back, because it's not going to work with some compliance thing set. Quartz, I do a lot of system hardening there. Yeah, I use a tool in this course, almost the entire course, we're using a tool called the Stig Viewer, and we are looking at, this is a checklist for all 452. This is RHEL 9 right here, how we harden RHEL 9, Red Hat Enterprise Linux 9, with like Rocky boxes. And we can go look at any one of these and see. PassWD file must be group owned by root. Okay, boom, that's already set. Good. And then I could claim that as not a finding and go on with my day. All right, so we did the lab. We did conditional logic. I said looking up the logic of and or to see if you understand the underpinnings of them. Yeah, I think most of us, if you've done the work, you figured out what that kind of looks like. All right. Yeah, I appreciate that, Robot. I'm showing everybody that we got the course over there for the do all the Linux, or the little shop for people that like swag and stuff like that. We do have a little shop. All right, so that's that whole one. Let's go do some conditionals and counting loops. So again, the focus of this, and by the way, guys, let me tell you a little bit about the cadence now. I'm gonna start doing these, like I did this on Sunday, and then I'm doing this tonight, and I'll probably do it tomorrow night again, and hopefully finish up most of the book. And then on Fridays, while I'm co-working, I'm just going to replay these for you. So people that missed the stuff during the week, I'm going to replay it all day on Friday while I'm working, because I can work on my other system. I got another computer over here. I can do that and not interfere with my normal work, but then you guys can also watch these. So if people want to catch up on Fridays during the day, you know, hang out, talk shop, I'll still be around to type. I just won't be talking during that. Okay. So let's go to this next lab. Conditional and counting loops. Right here. If anybody wants to follow along with me, here's the lab. Also, it looks like Robodom's showing you guys all about the YouTube stuff. You guys are welcome to hang out over there too if you want. Some of you are hanging out over there already. So this lab goes like this. You're a new system administrator at a company. We always start that way. You've decided that you need to start using loops to increase your productivity and monitoring of the system. Maybe you want to watch something as it occurs and you're like, hey, I don't know how to do it without pressing up and enter multiple times, so I need to learn how to do this. So we're going to create a conditional loop to watch CPU resources every 5 seconds. And then we're going to create a conditional loop to count to 10 with various different starting and ending numbers. So let's see if we can do that with a conditional loop, right? And what that'll look like here is we've got the while command. So while true, do uptime, sleep for 5 seconds, and then done. So every 5 seconds, this is going to pop up. Every 5 seconds, forever. So I often show people when you do a while loop like that, you're doing poor computer science. You're doing what's called an infinite loop, because the system is going to test true and it's going to evaluate to true. It's going to drop into the block of code between do and done. It's going to run the command uptime, and then it's going to sleep for 5 seconds, and then it's going to go back up to while, and it's going to evaluate true to true again. And it's going to do that forever until the system runs out of electricity or the heat death of the universe due to the second law of thermodynamics. One of those two things is going to happen, right? Or somebody just pulls the plug on my servers, right? Well, this is up in the lab, so this could stick around longer than that. But my poor servers sometimes just get unplugged. To stop this, as a sysadmin, we're going to hit Control C. So you could start it up again. It'll go every 5 seconds. You can play with it. Can I make it every 10 seconds? I think so. Make it 10 seconds right there. Then we maybe watch it. And we see that it does take 10 seconds. First one executed immediately, but then 10 seconds. Okay, that's what I expected. I hit Control C, and then now I can make a conditional loop by setting a number, so a variable like we saw earlier, to 0. I'm just going to set count to 0. And XShiny said it's fun. XOR gates was the speed breaker that slowed down AI development for close to 2 decades. Yep, that makes sense. Yep. So then we're going to set condition to 10. So now we got a count of 0 and a condition of 10. We could have picked any names for those. We could have called one red. We could have called one the green flag and one the checkered flag if we wanted. It's our names for labels on the side of the box as far as variables go, right? And then I just made this simple little, we're just going to say while count is less than condition, so 0 is less than 10, do echo I am counting count, so put the number, and then increment count by 1. So increment is stepping up by 1, done. Come back up and test the condition again. Is count still less than condition? Yes. Echo out count, and then increment. So we stopped on 9. If I echo count, I should see that count made it to 10. That's interesting. It's interesting, isn't it? It counted to 9 and then it incremented to 10 here. But then when it came to execute again, count was not less than condition anymore. So we didn't get any more executions. But count was still left at 10. Do you guys think that might be useful to know? Yeah, if you were going to then take the value of count and dump it into somebody's account or something as a banking function or something, you probably just dropped one more dollar in there than you intended to. Or you printed out the wrong value on their receipt from what actually happened. Both of those things will probably get you fired, right? As a programmer anyways. So we're not really necessarily worried about shipping code here. We're just doing stuff in our labs. But I want to know if something's going to count 10 times, which it did count 10 times. 0 is a counting real number. This counted through 10 times, but count was left one number higher. We need to think about our logic as we do these things. All right. I said, what happened with the count? Did it count the way you expected? Did I want it to start at 1? Do I need to... Oh, look, it just reconnected again. That's interesting. So I lost all my variables when that happened, so it's kind of interesting. Then we get done with conditional loops. Conditional loops were fun while something, but now we're going to do some counting loops. And counting loops are fun in that we're going to count over a list of things. Somebody knows at the start of a counting loop how big the list is. Either there's actually a list of number of items that we have, or we generate numbers programmatically and then loop over them, or we read the contents of variables from a file. All of these are useful as sysadmins, and all of these are good to understand how to do. So let's just take a bunch of numbers and just put them on the command line. Okay, and we counted that. But now I want to go to 100. So I don't think any of you would watch me get to 100. All the numbers would go to 0, right? Because you'd be like, what the hell's this guy doing? That doesn't make any sense. So let's programmatically create this list over here. And we're going to do that. Oh, by the way, we can also count over things. For dessert and cookie, cake, pie, you'll get your list. But then we come down here and I say, let's go sequence I to, for I in sequence to 1,000, do echo I am counting over I, and now it's going to count between I and, it's going to count all the way up to 1,000 here. We don't have to watch it the whole time, but we can. And the sequence is going to print all the numbers from 1 to 1,000, so we're just going to keep getting all the numbers. But we could also change that up and say, well, what if I wanted to do sequence starting at 5 and do every 5 numbers. So now we're going 5, 10, 15, 20, 25, 30, right? We can just keep going. Yep. And just keep counting up. Yeah, Quartz one, and he's got the loudest keyboard in there. I actually showed somebody my office the other day. Who did I show my office to? And they said, oh, you're one of those mechanical keyboard guys. And I go, no, not really. I mean, these aren't like super expensive keyboards or anything. Sequence will create a subshell? Sure. But it generated them all and dropped them in there. So now they're just executing over the actual... Executing right now. RobeDom, I knew a guy who did get paid to do that. And then he automated it all with these little keypads. And he showed them how to do like macros. And his team went from like 16 people to like 4 because the company didn't need all the other people anymore. It was just like a data entry job. And then he eventually got let go. And I was like, well, I mean, I guess that's how we move into the future or something. I don't know. All right, so let's create a file and populate it with some values. So we're going to have apple, banana, pear, grapes, and throw it in a file. And if we cat fruit, it's going to throw everything down in a file like this. So now we got a file with 4 values in it. Maybe those are names of servers, and we got to loop over a list of servers that some, manager from another team says, hey, can you just check real quick? Are my guys using up? My guys keep saying that they fill up all their data, like all their space. Can you check real quick for me? Yeah. And then you go, maybe you list over. So in this case, we're just going to loop over the servers or the thing. Sometimes what we would do is we would loop over a list of servers or something and hit them all. And then we would check to make sure that they were all mounted off the same share. And then the one server that maybe his guys were always complaining about didn't actually properly have the NFS or like the Isilon mount or whatever mount you're using. And it was just something local. So now your problem is you have these guys who they've been on one server just putting stuff local. And that happens more than you might think. Like some servers just not the way that we expect, right? Xfinity said, I love people who use mechanical keyboards in coffee shop. Oh, that's terrible. Like a typewriter, like they pull out an actual typewriter and they're typing. Yeah, I just use these. I have 2 of the same keyboards in my home lab here. And I mean, sure, they're like decent mechanical keyboards, but they were only like $30 each. They weren't like these $500 or $600 keyboards. And actually my wife over there has another one. So there's 3 of them in here. But yeah, some of these people have like massive amount of dollars in their keyboards and stuff. And I don't have that. I don't want that either. Like I'm not interested in being keyboard elite. Some of you guys know that. I say, what's an infinite loop? Why did we make one in the first command of the lab? Because infinite loops are great for sysadmining, but they're poor computer science, right? So they're great for us to loop at stuff, but it's not great for any of these other things. I said, how did that output of the conditional loop look to you? Did it expect the numbers 0 through 9? If not, what did you expect? Could you change that to count like you expected? Yeah, well, that was what we expected. It was interesting, though, that it was 1 higher than we needed to when it was all said and done. Can you modify the server check to get the number of packages on both servers? Why might you want to know this as an administrator or an engineer? Yeah, maybe could we modify the server check to get the number of packages on both servers? Yeah, so what was our server check? Did I do a server check yet? Oh, there's 2 servers we want to check. So we're going to make a list for control plane and node 01, and then we're just going to SSH to both of them for uptime. And maybe what I want to do, let's do that command again. But when we go over there, we're going to go to hostname, and then we're going to do dpkg-l, right? And that's going to pipe through word count-l, and we'll just see control plane and node 01. Does anybody see really quickly, like if I didn't tell you anything else about what I'm about to say, what do you guys think about that output right there? Anybody want to try to guess? That's funny, Akshanya. If I said that out loud, she'd probably be mad at me. Nope, now I have to. What? He said, why does your wife need a keyboard if she can simply press your buttons? She laughed. Yeah. No, she definitely presses my buttons sometimes. Okay, so your feelings mutual. Yeah, I can press her buttons too. Real quick, look at this, guys. If I said these servers were built with the same process and they were built the same way through the same like CI/CD pipeline or something, and you said, what's a CI/CD? And I said, continuous integration, continuous deployment, right? I built both of these servers the same way. Would you look at me with that sus face? Like, what's that face like? I'm not doing it right. Yeah, you'd be like, Scott, that's real sus. I don't think those servers were built the same way. One has 1,707 packages, and the other one has 822. So one of the things I told you guys, when I come to a new environment, I often get dropped in. I don't want to say like airdropped, but it's very similar. Like I get dropped into new environments, and I have to like rapidly see what the problems are that these people are dealing with. People are going to tell you what they think the problems are, but sometimes you land there and you go, "This is a nightmare." I couldn't administer this system if you made me right now do that, but that is what they're making me do. I'd be like, I have to like sweep up first. I have to get an inventory together. Where the hell's our inventory? We don't even have an inventory of all the servers. Boom. Well, we definitely don't have an inventory of all the packages because, geez, look at that. Those are two completely different build processes to get to 1,707 packages on one server and 822 on another, right? Yeah, Quartz. That's what I was going for. That one or have you seen the dog? It's like a little Dachshund or whatever those things are called. The little wiener dogs, and he's like, it's so funny, so stupid, so stupid and funny. Anyways, all right. So we did that, and then I said, now we're going to use some loops. We're going to decide to create a script that uses both of the loop types. So let's create some of those. Yeah, that stupid dog is really funny. So here's what our script is going to look like. We're going to create a script that connects to SSH over both servers and creates the necessary files, use VI or text editor of our choice to create something like this. So let's clear the screen. PWD VI, what did I say? File create.sh. And in here, I'm going to say, now, strictly speaking, shebang isn't really needed, but you want to know what a shebang is because sometimes it is needed. You say, what do you mean? If you're gonna always 100% of the time just always work in a bash environment, you don't really need a shebang line. But if you're gonna use like user bin Python or user bin Perl or some other interpreter, you do want to tell it at the top of the system there. Another similar reason, the reason I always use shebang, you'll always see them in my scripts no matter what, is because sometimes I'm jumping into a bin KSH or a bin CSH environment. And if my script is going to be in one of those languages, I have to modify it for that. I have to make sure that I know that. Or if I'm jumping into an environment that I know has all three and I want to force bash, even though KShell is the most common. So back in the day, especially with HPUX and AIX and stuff, you would drop into different shells, but sometimes you knew those other shells were there and you would force the default interpreter to use the interpreter you wanted. You're not really forcing anything. You could do it anyways, but my point is, if you're always using bash, shebangs, strictly speaking, aren't needed. But whatever. It is what it is. But that's saying shebang correctly. Okay. For service and NFS. Yeah, you could add each of those. Fair enough. Yeah, that would work. Okay, so for server in, and now we're going to cat those servers. Right? Now, I don't have to use a semicolon at the end of that anymore. I can just now say do SSH over to $server and then for I in. So now in each server I'm doing, like we're going further and further in, we're going to use sequence, and how many do we have to make? 1 to 100, right? 4 sequence and 1 to 100. So sequence defaults to 1, so that's fine. We're going to do touch temp file $I, done. We need to close out with a single tick, right? And then down here, we're going to say done. So for server in this, done. Do done. All right, it's good enough. Escape :WQ. We can cat the file if we want to. Oops, file. All right, that's what it says it's going to do. It's not a super pretty script, not a super functional script. Can we run it? Can we try to run it? Will it break? Also yes. File create. So, by the way, does anybody know why I use a ./ there? chmod 750 root file create. Does anybody know why I had to do the dot on the /? You guys want me to show you real quick? So where am I at? I'm in root's home directory, right? And if I do an echo of path, the path does not have the word root in there. Does everybody agree with me? Do you guys see the word root anywhere in this line right here? Colon delimited variable, nothing in there, right? Let's do something real quick. Let's echo. Oh shit, sorry. Path equals. So let's say path equals $path colon root. All right. Now, let me just go ahead and echo $path again. And do you guys see root at the end of it? Yes. And real quick, if we ls pwd where we're at, we're in root, right? So now if I just said file create .sh, it would just run. Root server. Oh. Servers.txt. Ah, well. That'll get you every time. Got to VI the file real quick. Hold on. It's because I put the .text on the end. I don't know what I was thinking. Servers.txt. Yeah. Whoops. Servers.txt. That was my bad. All right. But by the way, you can just run it like this now. And why does that run? Why did that work? Why did it do what it was going to do? It didn't log or anything, so we just have to hope it did what we thought it was going to do. The other is all the files. Well, the reason it worked without the ./ is because typically, almost universally, wherever you're at in the file system, you're not going to have the local path in your path. So in root here, pwd echo $path. And there's a very specific reason for that. It's a security reason. Dot is never in root's path, for sure. And that is because right here, if you were to go, let's run it again. It's not going to need to run again, but let's say. The reason that runs like it does is because I'm saying from here, dot is here and dot is always my parent. So from here, we're doing a relative pathing to execute that file. But that file can't execute locally, like root will never execute a local file. Because what if somebody could get you to move into temp and then do an ls, but ls happened to be a local file that they had maliciously put in like the one world writable spot that you have. And then your bash script or your bash user, bash shell inside it from a bash user, executed that with permissions on the system and took over the system. This is another reason why temp, which is always a world writable directory, is always no exec. So anybody can write bullshit there, but nobody can actually accidentally run anything out of it. So if one file, if I was the best way to find it. I would probably find, if one file had data, I would probably just do an ls-lah or something to see which one wasn't a zero file, an empty file. You do that. You could probably also order your files by size. I'm sure there's a way to do that with ls. I don't know it right off, but I'm sure there's a way to do that. Or you can do an ls-l and then sort them by that. Yeah, you could probably find for some. Yeah, there's probably a way to. I'm sure there's a bunch of ways to order stuff. I don't use ls for that a lot, but typically if I had that use case, I would just go look it up real quick. I would see if like man ls had, there's obviously a sort involved, but how can I sort, right? Can I sort by word, time, style, alphabetically by entries? What I might do is, again, I can ls-l everything in temp, right? And let's say one of these did have data. You could always sort by the number. So you can do a sort, and then that's the first field, that's the second, that's the third, that's the fourth, and that's the fifth. So I should be able to sort, sort -n5, right, by that field. Dash, is it, I thought it was n. Field. America, where's the source? Where's the I thought it was by field. I thought there was a way to do sort by field. What do I see? Oh, key. Key is the key def. It gives location type, so it's K. K5. There you go. And then that would be so that's the only file that's see, these are all directories. All these are directories of some type or something else. See how they're all D's? So the only file there that has any value to it is this bottom one right here. So I don't know. I mean, I wouldn't necessarily have a use case for that, but that would, I mean, that would work. You could also grep-v for 4096 if you knew that was unique. Kick all those ones out of there. But yeah, I mean, like this is one of these things. I mean, if you had anything more than just like a quick use case for something, then you would probably go build something to do it, right? Expected. All right, so that's that whole lab. All right, our next lab deals with package managers. Let's see, we're over an hour, so I don't know if we're gonna sit around and keep working on this, but yeah, we'll probably call it here. But we'll keep working on these throughout the week. I'll make a third one of these, and we'll just keep working on going through the labs and making sure that you guys touch the basics of Linux, right? All the other stuff that we do in the course builds more on doing it for the enterprise, but every now and then I like to go kind of back to the basics in the beginning and just do, you know, general Linux stuff. So, all right, I'm going to call this stream here then, go to our little end of stream thing. We don't have enough people to raid anybody, so I'm just going to call it for the day.